We now have another function here, and we are tasked to find the derivative of this using a definition. When we talk about the definition, it's actually a definition using the limit. Okay, so it's identified in this manner. The derivative of your function z is equivalent to the limit of your f of your z plus delta z minus f of z all over delta z as that delta z approaches to 0. Definitely, we can just not substitute automatically 0 for delta z because that would be undefined. So what we need to do here is to first identify the representation for this function because this function is already given as it is. And therefore, we are going to copy that later. But for the first one, you need to find its equivalent form. Allow me to use the scratch portion here at the bottom. Okay, we're going to find the form of z plus delta z for your f of z being equal to 3 z to the power of negative 2, right? Okay, if you don't like negative exponents, and of course you're going to implement this later on, we can also write this as 3 over z squared, thereby making our expression rational. Okay, because our by the law of negative exponent, we can put it down or move it down the entire expression, making the exponent positive. So similar here, if you have 3 times z plus delta z, you have negative 2. Basically, you will still have z over, you have your z plus delta z squared, similar to this form. Okay, or if you would like to, allow me also to break this into a quadratic trinomial so that we could have an easier implementation later on, because the goal is to find the limit and we are just trying to express this in another form. So we have to express it in a simpler form. This is 3 over z squared according to the special product or the square of binomial. You have plus twice z delta z plus the square of delta z. So we're going to take this together with this form now in our expression here. So let's continue, or start rather, solving for the limit, because the earlier process was just trying to get its representation or its form. It was actually 3 over, okay, so you have 3 over z squared plus twice z delta z plus the square of delta z minus the original form, now in rational expression, 3 over z squared. This is still all over delta z as that delta z approaches 0. Hence, we cannot again substitute automatically because we still have an undefined form here. But what we can do here is to take out our numerator and combine these terms as well. Probably we would see later on some expression that will allow us to cancel this if possible. So let me use again the denominator or the scratch portion at the bottom. Let us combine the numerator alone. Okay, so you will have here 3. If I'm correct, that's 3 all over. So let me redo it here. 3 all over z squared plus twice z delta z plus the square of delta z minus 3 over z squared. How can we combine this? Of course, with LCD, right? We have LCD. Our LCD is the product of the two denominators plus 2z delta z plus delta z squared times, we're going to have z squared here. Let's not multiply them in this time. Let's multiply them later on, as we are going to do it together with our numerator. Because when you look at this, our expression in our numerator will also be different from this, because we are actually having here equivalent fractions or rational expressions, or LCD. Take note that if we're going to do that, this would be a multiplier of the first numerator, and the second one will also be a multiplier of the second numerator. So you have z squared times 3 minus 3 times z squared plus 2z delta z plus the square of delta z. Okay, that's what will happen. Just like if you will have 1/3 plus 1, or let's say minus, because this is minus here, minus 1/2 minus 1/3. So 2 times 3 is 6. So you have 3 times 1 minus 1 times 2, right? They are being multiplied to the numerator. Same thing here. we are multiplying them. Let's combine the numerator, and together with that also simplify the denominator. You have 3z squared. We can actually now distribute this because it's just a coefficient. So minus 3z squared minus 6, that's 3 times 2, z delta z, and minus 3 the square of delta z, right? Then the coefficient is placed or multiplied to all the terms. As for our denominator, let's also use distributive property, but the left one, as we distribute that here, so you will have z to the power of 4 plus 2z cubed delta z, and then later on we'll have here plus z squared delta z squared. Okay, so we'll have that here. Now we need to combine what we can combine for our what do you call this one, our numerator and even in denominator. But since the denominator is really good as it is, let's stick to that. But for our numerator, we can combine that. Speaking for these two, okay, so we will have a simpler form, which is just negative 6z delta z minus 3 square of delta z. We cannot combine them because they are different, okay, over z to the power of 4 plus 2z cubed delta z plus z squared times delta z squared. Now this is now good, but take note, this is just a portion of our limit earlier function, because that is just the numerator itself. So allow us to write it here and continue. The limit, I'm gonna write this first here. So you have your entire numerator would be this one, 6z delta z, that's negative 6z delta z minus 3 times the square of delta z, right? All over. You will have here z to the power of 4 plus 3, sorry, that I believe it's 2, not 3. 2 z cubed delta z, am I right? 2z cubed delta z, right? And z squared times the square of delta z. But this is still all over this one because this expression is just the numerator, delta z. Okay. Now from this, again, this is still here. So what we need to do is to remove that, or probably do some operations or methods that I will actually remove that. How can we do this? This example is considered as a nested rational expression. We have a rational expression within a rational expression. So what we can do here actually is to use the keep, change, flip method, right? So we're going to keep the numerator, if you can remember, just like this one here, 1/2 over 3. So you keep your numerator, change the operation to multiplication, reciprocate your denominator. Actually, this is a 3, right? Okay. Reciprocate the 3, so you have 1/3. Keep, change, flip method. So you keep the numerator, negative 6z delta z, negative 3. If we're talking about numerator, the entire numerator, okay, over z to the power 4 plus 2z cubed delta z plus z squared times the square of delta z. This operation of division will become times, and reciprocate the denominator. Instead of delta z, that's 1 over delta z. Okay? We're doing this so that we can actually cancel that. Looking at our numerator here, where there are common delta z. We are not yet applying the limit. We are just manipulating that. So we have here the limit. When we factor delta z in our numerator, what remains is negative 6z minus 3 delta z, right? Because this is square. We take that out, so minus 6z. All over the same denominator, z to the power 4 plus 2z cubed delta z plus z squared times the square of delta z times 1 over delta z, this one here. And that time, okay, we can now cancel that delta z. And this time, we are now guaranteed that our limit will no longer be, it will be existing. The denominator will no longer be 0. Unlike this one here, as you substitute as z approaches 0, right? It's 0, so it's undefined. But this time, since we cancel this factor out, it's no longer 0. Even if we have delta z's here, because we have a term that is no longer having a factor of delta z. And if you're going to substitute that here and here, with this b2 becomes 0, we still have z to the power 4. And that's already good. Okay? So that's the next step we need to do here. Allow me to do that as mentioned. When we cancel that, we'll have the next step. Still limit. We haven't... I'm not going to substitute it first. Let's just simply write here minus 6z minus 3 delta z all over z to the power 4 plus 2z cubed delta z plus z squared, the square of delta z. Okay? As mentioned, we still have this as we now apply the value of z approaching to 0. So we will no longer use limits because this would be 0, that would be 0, this is also 0. What remains here is just simply minus 6z over z to the power of 4. Okay? Since your z is still, we can have cancel the z here. So this is a 3. What remains here is simply negative 6 over z cubed. This is now, finally, the derivative of the given function. Or if you would like to write it in similar way like this, you can move the z cube up. You have negative 6 z to the power of negative 3. But of course, this is more formal than this. But I'm writing this one because there are, of course, rules in differentiation that we are going to learn later on or relearn. And if we're going to use that, this would be your answer applying those rules in differentiation, which would also yield to this final answer. Okay, so stay put for those rules in differentiation later on. But in the meantime, this is the result of, or the derivative of the given function using the definition. Thank you very much for watching.